You know, what if I told you that the secret to absolutely crushing an exam, to debugging a tricky piece of code, or even to building smarter AI, what if it all came down to the exact same strategy? Today, we're going to dig into this one powerful principle that, it turns out, shows up pretty much everywhere once you know what you're looking for.
I mean, we've all been there, right? You're studying for a huge test, or maybe just trying to pick up a new skill, and you just feel completely swamped. You've got all these notes, these complex ideas, and it feels like you're just trying to keep your head above water.
And you know, this isn't just a feeling, it's a real problem. Check out this quote from a Reddit user, Professor Kopuis. They were using Anki, which is a really popular flashcard app, but they got buried under this avalanche of digital cards. It was stressful, it wasn't working, and they just knew there has to be a better way than trying to memorize a million tiny facts.
Well, the good news is there is a better way. And the solution isn't about just working harder or trying to cram more stuff into your brain. No, it's about a total shift in how you approach the problem itself. It's a strategy that can turn that overwhelming mountain into a series of small, manageable hills.
And this is it. This is the core idea that Professor Kopuis landed on. They called it divide and conquer. It's basically a two-step dance. First, you divide. You break a huge topic down to its absolute most essential core. And then you conquer. You build it all back up, but this time in your own words. So let's see what that actually looks like.
Okay, so first up, let's look at that very practical example, studying. How do we use this idea to turn a really dense chapter from a textbook into knowledge that, actually sticks around?
And what's so cool is how simple it is. The divide part forces you to figure out what's really important. You're not just highlighting stuff, you're boiling it all down. But the conquer step? That's where the real magic happens. When you can rebuild the whole concept from that one little sentence, that's when you prove to yourself that you actually get it. You're not just parroting it back.
And this right here is the secret sauce. This is why it works so well. Just memorizing facts is, well, it's pretty fragile. It doesn't last. This process forces what experts call deep processing. You're actually wrestling with the material. You're breaking it apart and putting it back together. That builds way stronger connections in your brain for knowledge that lasts.
Okay, so this whole idea is a game changer for studying, for sure. But where else does it pop up? Well, let's jump over to the world of computer science, where finding one tiny bug in millions of lines of code is like an everyday thing.
So a beginner programmer asked this question, and it's a great one. They're talking about a famous algorithm called binary search, and they're wondering, if it only works when a list is already sorted, what's the big deal? How useful can it be?
Oh, the big deal is speed. I mean, a staggering difference in speed. A linear search is like trying to find a name in a phone book by starting at A and reading every single name. It takes forever. Binary search is the divide and conquer way. You open the book to the middle, you see if the name comes before or after, and bam, you just eliminated half the book in one go. You keep doing that, having the problem every time. To find one item in a million, a linear search could take 1,000,000 steps. A binary search? It takes about 20.
But here's the really cool part, and it's what other people in that thread pointed out. Binary search isn't just about code, it's a way of thinking. Say you've got a weird bug in your browser. Don't check your add-ons one by one, disable half of them. Is the bug gone? Well, you just eliminated half your suspects in a single step. It's all about intelligently dividing the problem to conquer it way, way faster. All right, so we've got this great study habit from Reddit, we've got this foundational concept in computer science. They're both built on the same idea, but is there any hard science to back this up? Well, let's turn to a formal research paper about educational technology.
So researchers set out to answer a pretty specific question. They wanted to know if technology that actually personalizes learning, an adaptive algorithm, works better than just giving everyone the same material, the old one-size-fits-all method.
And guess how these smart, adaptive systems work? Yep, it's divide and conquer all over again, just a really sophisticated version. Instead of giving every kid the same 100 vocabulary words, the AI divides the problem, it quizzes the student, figures out they're weak on, say, science words, and then it conquers that specific gap by serving up exercises just for those terms.
So, did it work? What did the data say? Well, the results are pretty undeniable. On the final vocab test, the students in the traditional group got an average score of about 68. The students who used the adaptive divide and conquer system, their average was over 75. Think about that. That's a 10.5% boost. In a controlled study, that's a huge deal. It's solid proof that this approach of breaking down the problem of learning for each individual and tailoring the solution, it just gets better results, period.
Okay, let's step back for a second. We've just looked at 3 totally different areas: your own study habits, how programmers solve problems, and even AI in the classroom. Let's pull it all together and see the pattern.
And this table just lays it all out so clearly. Look, it doesn't matter what the domain is. The pattern is exactly the same. You divide the big, scary problem into a smaller piece, and then you conquer that piece, which gets you to the solution for the whole thing. Same logic, just different playing fields. So, what's the big idea here? It's really simple. When we're faced with something that feels huge and complicated, our first instinct is usually just to charge at it head-on. But the truly smart move, the universal strategy, is to stop and figure out how to break it down first. That's the real path to conquering complexity.
And that really leaves me with one final question for you. Think about your own life right now. A project at work, a new skill you want to learn, some challenge you're facing. How can you apply this? What's the next big, hairy, audacious problem that you can divide and conquer?